Look what we have going on here in problem 5. We've got that the daily cost, C, in dollars, for a manufacturer to produce X number of electronic video components is given by this function here. So the cost depends on the number of components that is made, and it looks like a logarithm function. So here's what we want to know. If we currently produce 70 components each day, by how much can the cost be expected to change if production is increased by 1 component each day to 71? All right, so we're going to increase by 1. We know that's a marginal. This is going to be the marginal cost, and that's just the derivative. So what we need to do here is to find C prime of x, and then particularly we need to find C prime of 70. So let's start with C prime. So I'm going to write C of x like this, actually. 4,000 natural log. Now I'm going to get rid of the radical because we know we don't deal with radicals. This is going to be what? 3x squared minus 800 to the, it's the cube root, so this is going to be 1/3. So now we've got 4,000 times the log of some argument. So let's differentiate. So we will get C prime of x equaling the 4,000 comes along. Now this is a log function. So log function is 1 over the argument times the derivative of the argument. So this is going to be 1 over the 3x squared minus 800 to the 1/3 times the derivative of this argument right here. We need to differentiate that expression. Well, this is a power, so we're going to bring the exponent down as a multiplier, 1/3, and then this is the derivative of the outside, right? 1/3, 3x squared minus 800, decreased by 1. Now, 1/3 minus 1 is negative 2/3, times the derivative of the inside, right? Remember, we got a power inside and outside, so here's the derivative of the outside. Now the derivative of the inside is, okay, here's the inside. I think we just get 6x. So we've got the calculus part done. Let's see if we can fix it up a little bit. So let's see. First of all, I noticed that this 3 will go into that 6 twice. This is a negative exponent, so let's bring this thing down. And then we're going to have, okay, now I've got the 4,000 times that 2. So I'm going to write this now as C prime of x equals, okay, the 4,000 times the 2 is 8,000. And we still have this x up on top, 8,000x over, now, here's, I'll write this whole step here. It's 3x squared minus 800 to the 1/3, but then we're bringing this whole thing down, right? That whole thing's going down. So it's 3x squared minus 800 to the 2/3, right? Positive 2/3. And then the 1/3 and the 2/3, that'll just give us 1. So I'll write it up here now. C prime of x is going to be this fraction, 8,000x over quantity, 3x squared minus 800 all to the 3/3, but that's just 1, right? So we get 3/3, just 1. So here's our derivative. C prime of x is 8,000x over 3x squared minus 800. There's our derivative. Now we need to compute this at 70. So C prime of 70 is going to be, okay, this is going to be a calculator or Wolfram Alpha problem here. I'll get 8,000 times 70 over 3 times 70 squared minus 800. And when I do this on my calculator, I am getting 40.28776 ... So I'm just going to round that off, and I'm going to say we're going to get an increase of about $40. And since it's money, I'm just going to round to 2 decimal places. So I'm going to say going from 70 to 71 units, we're going to increase our cost by about $40.29.